Okay, I'm gonna very quickly go through a brief hardware tour of all of the hardware that was used in this project. So as you can see, there is an x500 drone, or x500 quadcopter. Of course, you have a standard RC transmitter and receiver, just 6-channel in this case. We're using a Pixhawk flight controller, complete with many sensors such as IMUs, accelerometers, compasses, and of course the GPS. Then you have a telemetry radio for communication with the ground station. In this case, we are running Q ground control as the ground control software. That allows us to get lots of good information about the state of the vehicle. Like if I tilt it forward, you can see the orientation change. Yes, so we have our ground control station and we have our x500 drone. The last thing we needed to add was some capability to communicate over ROS. So what we have to do that is we have a companion computer on board. In this case is a NVIDIA Jetson Nano. This Jetson Nano is making its own Wi-Fi network through that little USB device you see there. Upon making that Wi-Fi network, the ground control station can connect to it, and it can connect to the ROS master running on the Jetson. So the Jetson is running the server side of our project, which you'll see described in the README, while the ground control laptop is running the client side. So the Jetson is receiving all the commands, all the inputs commands from the user through the ground control station, and then it is in turn communicating those commands over this USB serial device you see to the Pixhawk. And it is just doing that through a standard UART connection. So in doing so, we're able to send user-defined inputs from the ground control station to the Jetson, and then the Jetson will tell the Pixhawk to perform whatever autonomous behaviors that we want to do. So in this case, we are typically giving the Pixhawk either position set points or velocity set points, but we could also give it acceleration set points or body rate set points if you wanted to go deeper into the actual control of it. The only thing you can't do is send actual rotor speeds. But all that being said, we can quickly arm the vehicle just for fun since there's no propellers on it. Put you in a suitable mode and should be able to spin up the rotors. You can even give it a little juice. So yes, that is the system in a manual flight mode where all of the inputs are just coming from the sticks. However, what we're interested in is not a manual flight mode or even one of the Pixhawk's autonomous modes. We're interested in using off-board flight mode, which is where the Pixhawk is willing to accept commands from an external companion computer, such as the Jetson. This is great for doing what we want to do for controlling autonomous behaviors. However, it is dangerous because if you send commands for the drone to crash itself, it probably will. The Pixhawk has some safety features implemented, but they certainly will not save you from everything, especially from crashing into the side of a building or just flying away entirely. So yes, you will see the drone in action in the next demo video. Thank you.